I welcome you all for this lecture of process planning activities. This is the series of video lectures on process planning. Earlierly, we have seen over the role of process planning in industrial scenario and computer-aided process planning. Now, this lecture is followed by process planning activities and myself, Aravindan. So these are the contents of this video. Process planning parameters for calculating various production process. So we are going to determine what is the parameters going to influence the production process. Then followed by the selections of Zik and fixtures for assuring their quality. Then followed by a set of documents for process planning, economics of process planning. So these are the wide range of contents in this unit we are going to discuss, and in this lecture we are going to discuss about the process parameters, right? So finally end up with the case studies. So process parameters influencing machining. So whenever we are talking about that machining, there are some parameters will tends to usually influence. Generally, when you look into a quadratic equation, the variables which present on your left hand side, are usually a dependent variable. The variables on a quadratic equation on the right hand side are said to be your independent variable. The left hand side variable is most over dependent on the variable on the right hand side, right? In this video or in this lecture, we are going to evaluate the process planning parameters which going to influence the machining operation. Here I have shown a machining operation. For this particular machining operation, we are going to discuss what are the parameters are going to influence. When speaking about the process planning parameters, the main parameter is based on Taylor's two-life equation. What is Taylor's two-life equation? The Taylor's two-life equation is a methodology for determining the life of the tool. So Vt power n equal to C. You has been most over familiar with the term of Vt power n equal to C. V is nothing but your cutting speed, where T is your tool life, n is an exponential component, and C is your constant. When you are expanding this equation, the terms which I seen on my right image are my cutting parameters when my Taylor's two-life equation has been expanded. As we are speaking as a basics of machining, if an employee or a newcomer is going to start up the machining, what are the essential parameters he needs to identify? So first he is going to feed the job into the chuck, where he is going to lock the degrees of freedom, right? On that particular operation, no process parameters have been controlling has been stipulated, but once the chuck tends to rotate, that speed is an independent parameter which you are going to set out. That speed will determine the machining efficiency, right? So first you are going to load a workpiece on a chuck. That chuck is going to rotate. That chuck will determine the nature of the machining, and it is going to influence your machining parameter, right? Then next one, I am going to have my tool near my workpiece. My tool, I am going to set up a tool. The tool, when I am setting, whatever the depth of cut as well as the feed I am going to influence with respect to the tool is also going to be my one of the controlling parameter, right? So I am setting upon a chuck. So the setting upon a chuck, when I am trying to rotate the chuck, my cutting speed is going to be independent, which I am going to give, but the machining is depending on the cutting speed. Similarly, I am going to load my tool. The tool which I am loading, I am going to import a depth of cut as well as the feed. So they are also going to determine my machining efficiency, followed by the depth of cut, feed as well as the cutting speed for a cylindrical job. So these are going to have an influence on the machining surface. So that is the expansion of V into F into D into Taylor's two-life equation T equal to the exponential factor of C. So these are the basics parameters going to influence during the machining operation. So apart from this, the next terminology is cutting fluid. So the cutting fluid will influence, why I have listed this cutting fluid in the first term. When my cutting fluid has not been present at that moment, the following parameters of speed, feed rate as well as the depth of cut will tend to suffer due to the, when my cutting fluid is cutting fluid is absent, automatically what will happen, these bottom three parameters will tend to have a variation even on the absence of the cutting fluid. So for that reason, the process parameters which is controlling the machining, the cutting fluid is the first parameter. So these are our main aim and objectives for process planning, various process planning activities. They are used to identify selection of appropriate process parameters, appropriate speed and feed rates, followed by the specific number of process required for this production, followed by machining time. So these are the objectives which we are going to satisfy with our process planning activities. So what are the factors which is going to have a significant influence on process parameters? Now process parameters are going to influence your machining. Now how these process parameters is going to depending on something. So these process parameters, what are my process parameters? Cutting speed, feed and depth of cut. These three parameters will depend on the workpiece material as well as my geometry. Then followed by tool material and geometry. So you are going to stipulate the workpiece, you are going to stipulate your tool material. So the both geometry will play a vital role. Complex geometry will have a difficulty on machining. A simple geometry will have a quick amount of machining time. The processing time available for us to calculate, because the processing time is the main parameter. When you need to have a certain processing time for a certain object, you need to specifically provide the time, otherwise the product will not be as efficient as we like, right? Then next one. So this structure, I think you are been more clarity over this structure. This is one of the formulation of a martensite, and another structure is going to be a ferrite. For example, we can have a steel, making of steel as an example for this. Usually at a dry condition, steel is very hard for you to bend out, right? But the same steel, when it is heated to a red hot condition, what is happening there? The steel will tends to have a different behavior, whereas it is in a dry state, right? So these are the parameters influence the process parameters most, right? So on our next lecture, we are going to see over these process parameters influence how it is tends to inculcate and on the machining. So hope you all understand with this lecture what I have given for the process basics of process planning activities. We meet in the next lecture. Thank you all.